Greetings, math students, from Mrs. Marcellus and geometry guru Euclid. Today's lesson is Area of Composite Figures, Part 2. In the first part of this lesson, we focused on rectangular shapes, and today we're going to add in some triangles and trapezoids. Today's learning objective is students will find the areas of composite figures by creating models and by partitioning the figures, calculating the areas of individual polygons, and combining them. Today's vocabulary is a repeat of part 1 of this lesson. So what do you think, Euclid? Should we go straight to the examples? He's ready, so here we go. Let's find the area of this composite figure. We want to break it down into individual pieces that we know how to find the area of. While there are certainly other ways to solve, I think the easiest thing to do is to divide this into a rectangle and a triangle. The dimensions of the rectangle are 6 inches and 10 inches, so to find the area, we'll multiply 6 times 10 for an area of 60 inches squared. To find the area of the triangle, we need its base and height. We can see clearly from the picture that the height is 4 inches, but we need to know the base. The opposite side of the rectangle is 10 inches long, and we can use that to determine the base. The picture shows us that part of the distance is 6 inches, so to calculate the base, we will take 10 minus 6 to find that the remaining distance is 4 inches. To find the area of the triangle, we'll multiply the base of 4 times the height of 4, which is 16. Then we'll divide that by 2. The area of the triangle is 8 inches squared. To find the total area of the figure, we will add 60 inches squared for the rectangle plus 8 inches squared for the triangle to get a total area of 68 inches squared. In this composite figure, it's pretty straightforward that we have a rectangle and a trapezoid. Let's first find the area of the rectangle. To calculate its area, we'll multiply the base times the height, or 40 times 25. The area of the rectangle is 1,000 yards squared. To find the area of the trapezoid, we first need to know base 1, base 2, and the height. It's clear that one of the bases is 65 yards. We can use our knowledge that opposite sides of rectangles are congruent to find that the second base is 40 yards. Now we just need the height. The drawing states that the total height of the figure is 55 yards. The height of the rectangular portion is 25 yards. To find the height of the trapezoid, we can subtract 25 from 55 and find that it is 30 yards. Now that we know all the pieces, we can calculate the area of the trapezoid. First, we must add the bases, or 65 plus 40. This is 105. That gets multiplied times the height of 30 and divided by 2. 105 times 30 is 3,150. When we divide that by 2, we find that the area of the trapezoid is 1,575 yards squared. To find the total area of the figure, we must add the areas of the rectangle and the trapezoid together. This would be 1,000 plus 1,575 for a total of 2,575 yards squared. Let's find the area of this final figure. We'll look at 3 different ways to approach this problem. Let's first solve by dividing this into a rectangle and a triangle by drawing a line here. We can calculate the area of the rectangle by multiplying its base of 12 times its height of 4 for an area of 48 feet squared. To calculate the area of the triangle, we'll need its base and height. To find its base, we can use the opposite side of the rectangle. The full length of the side of the rectangle is 12 feet. From here to here is 8 feet, so we can find the missing piece by subtracting 8 from 12. This tells us that the base of our triangle is 4 feet. Next, we need the height. Be careful, the height of the triangle is not 10 feet. 10 feet is the height of the entire figure. The height of the rectangular portion of the figure is 4 feet. To find the height of the triangle, we'll subtract 4 from 10, which is 6 feet. Now that we know the base and height of the triangle, we can calculate its area. We will multiply the base times the height, or 4 times 6, which is 24, and then divide by 2. This gives us an area of 12 feet squared. To find the total area of the composite figure, we will add the area of the rectangle, or 48 feet squared, plus the area of the triangle, or 12 feet squared, to get a total of 60 feet squared. A second way to find the area of this figure is to divide it into a rectangle and a trapezoid. Using the dimensions of 8 feet and 4 feet, we can calculate that the area of the rectangle is 32 feet squared. To calculate the area of the trapezoid, we will need base 1, base 2, and the height. We can see clearly that one base is 10 feet, and we can use our knowledge that opposite sides of rectangles are congruent to find the second base is 4 feet. Now we just need the height. The height is part of one side of the rectangle. The total length of the rectangle is 12 feet. We know that this part is 8 feet, so we can find the missing piece by subtracting 8 from 12. This tells us that the height of our trapezoid is 4 feet. Now that we know the bases and height, we can calculate the area. The area of our trapezoid will be base 1 plus base 2, or 10 plus 4, which is 14, times the height of 4, divided by 2. 4 times 14 is 56, and 56 divided by 2 is 28. The area of the trapezoid is 28 feet squared. To find the total area of the figure, we will add 28 for the trapezoid plus 32 for the rectangle for a total area of 60 feet squared. Let's look at one more way to find the area. We could make one complete rectangle, then subtract the part that's not included, which happens to be a trapezoid. The overall area of the rectangle would be 10 feet times 12 feet, or 120 feet squared. Next, we need to find the area of the trapezoid and subtract that. To do that, we need the two bases and its height. We can see that one base is 8 feet, and since the second base is the opposite side of the rectangle, it is 12 feet. We also know that the total height of the figure is 10 feet, and the rectangular portion of that height is 4 feet. To find the height of the trapezoid, we will subtract 4 feet from 10 feet and find that it is 6 feet. Next, we'll calculate the area of the trapezoid by adding the two bases together, which is 12 plus 8, or 20, multiplying that times the height of 6, and dividing by 2. This gives us 120 divided by 2, which is 60 feet squared. To find the area of the blue composite figure, we will subtract the area of the trapezoid, or 60 feet squared, from the overall rectangle and find that it is 60 feet squared. 3 different ways to approach this problem that all result in the same answer. You need to solve in whatever manner is easiest and makes most sense to you. Well, Euclid, sadly this brings us to the end of our unit on two-dimensional geometry, but it's been really great working with you, and I appreciate all of your help. Perhaps you can stop in on me and Barkimedes as we tackle three-dimensional geometry next. In the meantime, we're signing off for now, math students.